So we're still in Chapter 1, Section 1. We're going to look at some very, very simple applications in this section. The next section, 1-2, has the more difficult applications. But this one's going to have some very, very basic ones. And we're also going to learn how to use different formulas. So let's go ahead and learn how to convert from Fahrenheit to Celsius or back and forth. So for temperature, we have two scales. We have the Fahrenheit scale and we have the Celsius scale. So your Fahrenheit scale is going to be 9/5 C plus 32. So that's one formula. Your Celsius scale relating to Fahrenheit is going to be C equals 5/9 times F minus 32. And we're going to use these formulas to convert back and forth. And when we work with the temperatures, we're going to be using a decimal. So we're going to be rounding to the nearest tenth of a degree. So we're going to be rounding to the nearest tenth of a degree. And we're going to be converting from Fahrenheit to Celsius or Celsius to Fahrenheit. So it's round to the nearest tenth. And let's go ahead and convert. And let's go ahead and convert. How about 10 degrees Fahrenheit? So we want to convert now 10 degrees Fahrenheit to what that would be in Celsius. So what we look at is we look at what we want. Okay, we want to find C. We want the Celsius degrees, right? We've got the Fahrenheit temperature. We want to get the Celsius temperature. So that means that we are going to be using this one because that gives us what we want. We want to find the Celsius temperature. We are given the Fahrenheit temperature. So we're going to be using this formula. Minus your 32. And we'll go ahead and plug our values in. So now we've got C equals 5/9 times F, which is 10, minus 32. So plugged our values in. And then we've got 10 minus 32. Well, 10 minus 32, that's a minus 22. We're going to convert this to a decimal at the very, very end. You don't want to convert it too early. Now let's go ahead and multiply. So this, remember, is over 1. So 5 times a negative 22. That's going to be a minus 110. 9 times 1 is just simply 9. Now we can convert this, and we want it to the nearest tenth of a degree. So we convert this to the nearest tenth of a degree. That's going to now be a negative 12.2, and that's going to be in degrees Celsius. So that Fahrenheit temperature of 10 degrees comes out to be a negative 12.2 degrees Celsius. So these are our two formulas. You'll either use one or the other, depending upon which one you need. So if they give you the F and you want to find the C, you use this one. If they give you the C and you want to find the F, you use this one. The one in your homework is very, very similar. Next, we're going to talk about simple interest. And simple interest is I equals P R T. And let's identify what those pieces actually mean. So I is the interest earned. P is the principal or the starting amount. R is your percentage rate as a decimal. And T is the number of years. Now we have to be very careful with T. Okay, T is the number of years. So when we look at this, if they give it to you in months, we're going to have to convert that months to years. So we're going to be dividing by 12 if it's in months. So when we look at these, we have to be very, very careful. And we always make sure that we convert that months to years if we need to. And we do not round into the very, very end. If you round too early, you'll be off by a few cents. So we never, ever round until the very, very end. So we'll do 2 of these. And then that should finish out this section. So here's an example. So let's say I have $15,000 in a CD that pays 6% interest for 17 months. What is my interest earned? And what is my total amount? So I have a CD. It's worth $15,000. So I go to the bank. I put $15,000 in a CD, and that CD is going to pay 6%. And I'm going to keep that in that CD for 17 months. And I want to know, how much money did I earn in interest, and what's my total amount? So the first thing we need to identify is write up our formula, then identify the different parts. So our formula is I equals PRT. And whenever I use a formula, I like to always write it down. That way I have it and I can see it. Okay, so it's all right there. Now, our interest is the part that we don't know. We want to find that. Now, the principal is how much money I have to begin with. So I'm going to put $15,000 in that CD. So that's going to be my principal. Then we've got our interest rate. Now, do not leave it as 6%. As a decimal, your interest rate would be 0.06. Maybe you have to move it 2 places over to convert that percentage to a decimal. And where we really need to be careful is with our time, because our time is not 17. Because if I said time was 17, that would mean I put it in there for 17 years. And I'm not putting that in there for 17 years. I'm putting it in for 17 months. So since it's in terms of months, I have to divide that by 12. Now, do not convert it to a decimal yet. We are going to convert it at the very, very end. If you take 17, divide it by 12 now, and round, your answer will be off by a little bit. So we're going to round at the very, very end. We keep the fractions, and the very last thing we do is divide and round. But not until the very, very end. So let's go ahead and plug in our formula, numbers into our formula. So now we have I equals, we've got our 15,000. We're going to multiply that by 0.06. And then we're going to also multiply that by 17 over 12. Now, multiply across the top. So if it helps, you can put this all over 1. And what I want you to do is just take a calculator and multiply across the top. So let's take our calculator. Hopefully we can see it here. Yep, and we can see that. Yep. We go to the glare here. We're just going to go and multiply straight across the top. So we've got our 15,000. We'll multiply that by 0.06. And then we'll multiply that by 17. And that gives me 15,300. And that's going to be now over 12. Notice I did not divide and get my decimal until the very, very end. Last thing you do is divide. So now we've got this. We need to divide it by 12. So we'll divide this by 12. And then we'll round out to the nearest cent if we need to. Doesn't look like we need to, because that's going to be coming out to be $12.75. And so what is that? That means we earned $1,275 in interest. How do we find the total amount? Well, the total amount is going to be 15,000 from the original plus the 1,275, and that gives us then a grand total of $16,275. So that is your total amount here, and there's your interest. Very, very important though, I did not divide into the very, very end. Sometimes if you divide too early and you round, you'll end up being off a little bit. So never ever divide into the very, very last step. Let's do one more of these. And then we'll move on to the next section. Okay. So let's say John borrowed $7,500 at a rate of 6.35% for, let's say, 9 months. Find the interest that he pays and the total amount. So we've got the amount of money that we borrowed, $7,500. We borrowed that at 6.35%. We did that for 9 months. We need to figure out how much interest we've got to pay and how much money do I have to actually owe the bank at the end. Write up our formula. I equals PRT. So in our case, the interest again is unknown. Now the principal is going to be that $7,500 because the I is unknown. We don't know that. Principal is $7,500. Be careful with your rate. As a decimal, we're going to move it 1, 2 places. So my interest rate would be 0.0635. My time again is not 9. 9 would mean 9 years. We're not taking out this loan for 9 years. We're taking it out for 9 months. So that's 9 over 12. And you can leave it as it is, or you can reduce it, right? Because 9 and 12 both have a 3 in common. So I could actually reduce that down to 3/4 if you want it. or you could leave it as it is. Doesn't matter. We're not going to make that a fraction until the very, very end. This one, it wouldn't matter. But on these, you never want to turn it into a decimal until the very, very last step. If you do it too early, you'll end up being off by a little bit. So let's go ahead and plug our numbers in. So we've got I equals 7,500 times 0.0635 times 3/4. So we'll multiply across. And that gives 1428.75. Notice I didn't have to round it to the very, very end. I'm going to divide that by 4. Okay. And now we divide. Now we can round to the nearest cent. So we divide that by 4. We're going to have to round to the nearest cent. And so that's going to be $357. And if we round, 19 cents. So let's make sure we know what that is. Okay, the interest owed, in this case, is going to be $357.19. That's my interest owed. How do we find our total amount? Well, for our total amount, we take our original principal of $7,500. We're going to add to that the $357.19, and then that gives me now a grand total of $7,857.19. So there's my interest that I'm charged at the bank, and this is how much the loan actually costs me. And this is simple interest. When we progress through the course, later on, we will learn about compound interest. And that's how banks usually charge interest, is compound interest, but that's a later chapter. Okay, that's one of the later chapters. That's in 4 when we talk about compound interest. But right now we're just focusing on simple interest. So that now takes care of 1-1. And we're now going to move on to 1-2. And all of these are a little bit different. These are our applications. These are all linear applications. I'm going to work through questions from your textbook, and I'm going to try to pick a couple of each type. We have several types. We have geometric figure type of formulas, where we have to use a geometric figure to solve it. We have the mixture problems, which I'm sure you're familiar with or heard of before, investment problems, and distance problems. So those are the big 3-4, the big 4. We also have consecutive integers as well, and some triangle problems, but it's mostly investment, mixture, distance formulas, and the geometric ones that we're going to be focusing on. So I'm going to try to do a couple of each type. So let me pick a couple of these for us to look at. We're going to start with geometric figure problems. Now, anytime you need a formula, they're going to be located in the back cover. So if you ever need a formula, use the back cover of your textbook. Every type of geometric figure that we encounter, the formulas are here for it. If you have your textbook, you can turn to page 119. If you don't, that's fine too, because I'll put it up on the screen. And we're going to begin with question 15. So page 119, we're going to look at question 15. Now, how I work through these questions is the very first thing I do is I read it. So I go through and I read it. Just like I would any other sentence, paragraph, I read it. Then I go back and I read it again, and I stop at every period or comma, and I try to figure out what I need to write down. And then I try to come up with my figure if I need one, and then I look up my formulas, and then I solve it. At the very end, then I go back and I work with units. So I don't label with units until the very, very end. If you have units too early, it gets confusing. So we're going to try to go through 15. Perimeter of a plot of land. We're just going to read it. So the perimeter of a triangular plot of land is 2,400. The longest side is 200 feet less than twice the shortest. The middle side is 200 feet less than the longest side. Find the lengths of the three sides of the triangular plot. So, what are we looking at here? We're going to be looking at a perimeter. So the perimeter of a triangular plot of land is 2,400. Now, what does perimeter mean? Perimeter is, irregardless of the geometric figure, perimeter is simply the sum of all the sides. Now, you could look it up, or you can just remember the perimeter is just simply sum all sides. And in our case, our perimeter is going to be 2,400. I do not put the feet on our units of measure until the very end. If you start putting on units early, it gets confusing. So we know our perimeter is 2,400. Now, what type of figure is this? Okay, this is going to be a triangle. And how many sides are in a triangle? 3 sides are in the triangle. So for a triangle, we have the 3 sides. And we have a short side, middle side, and we have the longest side. So for a triangle, we have 3 sides. Now, I like to write these up in words. So we're going to write them up in words first. Then we're going to put our variable in. So let's now read this again. We're on the second sentence here. The longest side is 200 feet less than twice the shortest. So the longest side is here. And the longest side is 200 feet less than twice the shortest. So that's going to be 2 times the short side. Less means we subtract, so less 200. So longest is going to be twice the shortest side minus 200. Okay, so here we are here. The middle side is 200 feet less than the longest side. So the middle side is going to be the longest side minus 200. Now, one of these we know nothing about. All right, and do we know anything at all about the shortest side? No. So the one we know nothing about, that is going to be our variable x. And now we can rewrite this with our variable x. So our short side is x. What about the middle side? Okay, the middle side is the longest, minus 200. We'll come back to that one. What about our longest side? Our longest side is 2 times the shortest one, so that's 2 times x minus 200. Now, what about our middle side? We haven't done that one yet. We had to purposely wait because it has the longest part here. Now, what is the longest one in terms of x? The longest one is 2x minus 200, right? Minus another 200, because that's this piece right here, because you still have to subtract off that 200 again. And so that condenses down now for the middle side to be, when we combine everything together, 2x minus 400. So these are our different parts here. X, we've got 2x minus 400, and we've got 2x minus 200. So is everyone okay with that so far? So broke it down. I like to use words, transform it into the variables. Now let's think about what we have. What did we talk about a moment ago? Well, a moment ago, we talked about our perimeter. And the perimeter was the sum of all the sides. So the perimeter is going to be the short side plus the middle plus the longest side. And we know from the problem specifically that our perimeter is 2,400. So that comes down. So perimeter is 2,400 there. Now we just replace, what do we replace the short side with? Replace that with x. What do we replace the middle side with? 2x minus 400. And what about the longest side? That is 2x minus 200. Okay, so all the pieces are in place. So put each piece down, we labeled them, and we filled them in. Now we can combine and we can solve. So now we've got 2,400 equals, let's combine all of our x's together. We have 1, 2 more, makes it 3. 2 more makes it 5x. And then minus 400, minus 200, that makes it a minus 600. Just combine. Now we can easily and quickly solve it. So let's move that 600 over. And I'm going to rewrite it so my x is on the left. So I'm going to rewrite this now as a 5x, because that's this piece. It's going on the left now. That way it's on the left. And then we've got 2,400 and 600. Makes it 3,000. Now we can finish it. So we divide by our 5. And that gives us now x equaling 3,000. Divide that by 5. It should come out to be 600. Okay, but this is not our final answer. Right? We're not done yet because we want all 3 sides. Now we're going to fill it in, and now we're going to use our units. So the short side, well, that was x. So the short side is easy. And it was in feet. So the short side is going to be 600 feet because our problem had feet in it for the perimeter. So our answers are going to be in terms of feet. Then we've got the middle side. And the middle is 2x minus 400, which is then 2 times 600 minus your 400. And that comes out to be now 800 feet. And finally, the last one, which is the longest side. And the longest side is going to be 2x minus 200. So that's 2 times 600 minus 200. And that gives you then 1,000 feet. So those are the sides of our triangle. 600, 800, and 1,000. Let's do one more of these. Let's look at question 17. And this again is going to be on page 119. So question 17 on page 119. And what this one is this one's looking at a shipping container. And we're looking at a volume. Now, volume are in cubic units. And we're going to have to use the back cover of our textbook to get the correct formula. So we're going to look now at 17. This is on page 119. We're going to look at question 17. And so we're looking at a storage container here, shipping container. And we're going to first read it. That's what we always do. We always read it first, and then we go back and we look at each piece. We try to figure out how we're going to use the information. A storage bin is in the shape of a rectangular box. Find the height. The box is 18 feet. Width is 8 feet. Surface area is 496 square feet. Okay, so that's what we've got. Now, when I look at this, what figure is this? What does it look like? Well, if I go to the back cover of my textbook, that's what our picture looks like. So let's go to our back cover. It's 3 dimensions. And so if I look at it, doesn't it look like a rectangular solid? Okay, it does, doesn't it? And we're looking at the volume because it tells you about the volume. So here's our formula for the volume of that rectangular solid. So the volume V is just simply all the pieces multiplied together. Length times width times height. So when we draw our picture, we can go ahead and label it. And the length is going to be 18. The height is unknown, so they want us to use a little h there. And it's 8 feet wide. And what is known? Well, what is known from the question? The volume is, it tells us specifically, 496. So that's our volume. So from the question, let's write this as from. So from the question, the volume is going to be 496. We looked up our formula from the back cover of our textbook. We've got everything labeled out. So this is going to be our height. This is the length, and this is the width. Now we can finish it. So we've got 496. That's going to equal then 18 times 8 times your h. And 18 times that 8, that's 144. We've still got the h with it. How do we finish it? We divide it by 144. Those all cancel, so that gives us then h is going to now equal 496. It's hard to see there, but we've got 496, right? Divide that by 144, and that's going to come out to be, now, it says we want it to round. How much does it say to round here? Finally, so let's make sure I added everything right here. Okay, so 496, which is there. 18 times 8, that's 144. So 496, make sure I didn't make a mistake. Divide that by 144, and that came out to be 3.44. Okay, and I believe somewhere it says we want it to the nearest foot, I believe. Okay, we want to find the box. Okay, the height of the box is unknown, so that is here. Right, it is 8 feet wide, length of 18 feet, so multiply those together. Oh, wait, I made a mistake. Okay, so it's, where did we make the mistake at? And I should have been more careful. I wasn't very careful, and sometimes you do this. We learn from our mistakes. Now, what did I actually find? I found the height, but I found it wrong. Now, where did I make the mistake at? Let's go back and read it. I got in a hurry, which sometimes you do. Okay, but we're going to learn from our mistake. I realized when it came out to be a decimal that repeated itself that I probably made a mistake. Where's the mistake at? Well, that 496, I got in a hurry, okay, and I made a mistake. I said that 496 was the volume. That 496 is not the volume, is it? Right? What is it? Surface area. Now, how did I know that I probably made a mistake? Well, on most of these, when you work them out, you should get a whole numbered answer. I got a crazy decimal on that, so I knew I probably made a mistake somewhere. So I used the wrong formula. So let's try to rewrite this, and let's try to use the correct formula. And we learn from our mistakes. I always like to go back, reread things, make sure I didn't make that mistake. And I realized I made the mistake at the very end, but that's okay, because this came out to be a decimal. So let's go back and try it again. Okay, we learned from our mistake. We picked the wrong formula. We did everything correctly. We just picked the wrong formula. Mistakes happen. If you make a mistake, just go back and start over again. So let's retry this and let's label things correctly. And I should have been more careful when I labeled it to begin with. So now let's label it correctly. This is where it's very important that I label it. If I would have labeled it, I would have been fine. So that 496 is not our volume. 496 is the surface area. Right? Okay, because that 496 should be the surface area. We did the volume. So you see the mistake there. Mistakes happen. How did I know I made a mistake? It didn't quite make sense. I got some weird decimal, and it probably should have been a standard foot. It's probably not going to be a decimal. So I realized I made the mistake. Now let's go back and let's try to get the correct formula. This one's actually a little bit more complicated. But here's our surface area formula. This is the one I should have been using. Okay? I did the volume. I should have done this one. So let's write down our formula, and let's do this question correctly. Okay, so we need that surface area. And surface area is S. And surface area is 2 HW plus 2 LW plus 2 LH. And that was my mistake a minute ago. We did the volume, which was much easier, but it's not the correct question. So we need that surface area. Now, what are our components? Capital H, we use an H. to represent the height. The width, we use 8, and the length, we use 18. Now when we work it out, we will get the correct answer, and it's going to come out to a whole foot. And that was my mistake, but we're going to fix that. And use common sense. If something doesn't look right, it probably is not. We probably made a mistake. So S, surface area, 496. We have 2. Height is h. Width is 8. We have 2 times 8 times 18. And we have 2 times 18 times the h. Now we can finish it. Now we've got it all correctly done. Sorry about the mistake, but we learned from that. We realize you have to be very careful when you pick the formulas. And don't get into too much of a hurry. So let's go ahead and multiply. 2 times 8, that's 16h. We have 2 times 18 times 8. That's 288. And then we've got 2 times 18, which is then 36h. Go ahead and combine the h's together. So 16 and 36, well, that makes it now a 52. H plus 288 equals 496. If I'm going too fast, just be sure and say something. Now that we have the correct formula, we're plugging in the correct values, and it should come out to be to a nearest foot. And I knew I made a mistake because that one did not say anything about rounding. So it should come out to the nearest, it should come out to a whole foot. That's how I knew I made a mistake when I reread it again. We now move that 288 over. And I'm going to put the 52 on the left because I like to put the variables on the left. And 496 minus that 288. That is now 208. And now when we divide by our 52, we get a whole numbered answer. And 208 divided by 52, that comes out to be 4. We want it in terms of feet, so my answer is 4 feet. So that storage container is going to be 4 feet, or sorry, 4 foot tall. Okay, so make sure you're careful. Make sure you use the correct formula. Never second guess yourself. If you get to the end and you think something doesn't look right, it's probably not. Like if I'm doing a question that involves the speed of a car and I get that car to be 200 miles an hour, it's probably not going to be right unless it's some kind of race car. If the time is some odd amount of time, it's probably not correct. So always look at it in terms of the context of what it is. Does it actually make sense? Would you expect a storage container to be 4 foot tall? Yes, it could be 4 foot tall, right? They're stacked on top of each other. So that's a reasonable answer. If it would have said 20 feet tall, that would be too tall to even fit on a semi, and you wouldn't want that. So 4 foot tall, that seems like a plausible, conceivable answer. So now we've looked at the geometric figures. Now we're going to move on to the distance problems. All of these are a little bit different, but when we look at distance problems, we have to consider the direction. When we look at the distance problems, we represent them with arrows. Okay? And these are going to be our vectors. Now, they can either add together, equal each other, or subtract from each other. Two cars going in opposite directions. Add together. So two cars going north-south. add together. Two cars heading towards each other like this. They add together. So those are our addition. Those are all addition vectors. If they overlap, they subtract. So when we talk about subtraction, they're going to overlap. So these are people running a race. Okay? One person is running faster than the other, and we look at the difference between them, so that's going to be subtraction. So overlap is subtraction. If they overlap at all, that means we subtract them. And when do they equal each other? Well, they equal each other when they're the same. When you're going to work and you're driving back home. They should be the same distance, right? If it's 10 miles to work, it's 10 miles back home. That never changes. So they equal each other. So if they're the same, like this, then they equal each other. So these are our three different scenarios. Add together, subtract from each other, or equaling each other. We're going to start off with one very, very simple question, and then we're going to look at a harder one. Question 23 is the easiest one. Out of all the questions, this one is definitely going to be our easiest one, and I think it's a good place to start. This is on page 120. We're going to look at question 23. And very, very simple question. This is a good one to start with. We'll do a more difficult one after this. The Apple Hill Fun Run. Mary runs at 7. Janet runs at 5. If they start at the same time, how long will it be before they are 1.5 miles apart? Now, whenever I write these, I always write the faster person on top. So who's the faster one here? It looks like Mary's going to be the faster one. So Mary's going to be the faster person. And her vector is going to be longer than the other. And for Mary, we have a rate of speed, which Mary's rate of speed is 7. And we don't know the time, so I'm going to use an x. You can use a t, or you can use an x. I'm going to use an x. So this is what we've got so far. We've got Mary. We've got our vector. Vector just means the arrow. Mary is going at 7, unknown amount of time. And she's racing against Janet. And Janet's not quite as fast. So Janet's rate is 5, and Janet's time is the same. It's unknown, and so that's an x. These are going to be subtracted from each other. And how do I know that I'm going to be subtracting? They overlap, right? If they overlap, you've got to subtract. And I always make sure that the larger, the faster person is on top. That way it stays positive. If you do it the other way, you'll get the same result, but your answer will come out negative. And so I always like to make sure it stays positive. That way there's no confusion. And so I always write the fastest person on top. Now we need to talk about our distance. And when I think about driving a car, there are 3 things that go into that. When I drive a car, there's a time, how long it takes me to get to my destination. There's a rate of speed, how many miles per hour I'm traveling at. And then there's how many miles I drive. So rate, time, and distance. So how long it takes me, miles per hour, average speed, and how many miles did I actually drive. Now we're going to apply that to this. And so when we talk about distance, we use this formula. Distance equals now the rate times the time. And so we're going to start with each of these, and we're going to be subtracting because they overlap. So we're going to start with Mary. And when I look at Mary, Mary has a rate of speed of 7, unknown amount of time, x. So multiplying those together, Mary's distance is 7x. We're going to be subtracting them from Janet's. And Janet's rate of speed is 5, unknown amount of time, x. And that's going to equal the distance apart. And this is from the problem. So this is going to come from the problem or from the question, and it says we want them to be 1.5 miles apart. So that's going to go right there. Now we can easily solve this. And 7 minus 5 is 2x. Divide by our 2. And that gives us now x equaling 1.5. Divide that by 2. It's going to be 0.75. Now, how can I write my answer? And what is it? Okay, x is the time. So you could write it in a variety of different ways. 0.75 is a number of hours. So you could write this in either of these three ways. You could write this as 0.75 hours. That's one way of writing it. Or you could write that as 3/4 of an hour. Or you could even break that down into minutes. Because 3/4 of an hour would be 45 minutes. It doesn't specifically say, so I would take any of these three. All of these are going to be correct. Sorry about that. So these are our three answers here. I would take either of them. You could leave it as 0.75 hours. That's okay. 0.75 is 3/4. You could write that as 3/4 of an hour. Or you could even write that as 45 minutes because 3/4 of an hour is 45 minutes. Okay. Let's go ahead now and take a short break. Then we'll come back and finish up this section. And if we have time, we'll start 1-3. We'll see how far we have as far as time goes. We may or may not get to 1-3. But we'll get to it next week if we don't get to it. Or on Wednesday if we don't get to it today. So let's meet back here at about, how about 10:55? So about 10 minutes.